Hello, fellow explorers of the ever-expanding universe of knowledge. I'm Ernis, your friendly neighborhood academic Sherpa, here to guide you through the dense jungles of research papers. Today, we're strapping on our thinking caps and diving headfirst into a fascinating paper, ViPER, Empowering the Self, Evolution of Visual Perception Abilities in Vision Language Models. Get ready, because this one's a doozy. Now, you might be asking yourself, Ernis, what in the cosmos is a vision language model? Well, imagine you're trying to describe the Mona Lisa to someone who's never seen it. You could talk about the subtle smile, the sfumato technique, the play of light and shadow, but without the visual, they're only getting half the picture. Vision language models, or VLMs, are like artificial brains that can process both images and text, creating a richer, more complete understanding of the world. But here's the rub, these models, despite their impressive abilities, often struggle with the finer details of visual perception. Think of it like trying to appreciate the intricate details of a nebula through a blurry telescope. You get the gist, but you're missing the breathtaking nuances. The paper argues that this limited capacity for fine-grained visual perception presents a critical bottleneck for VLMs in real-world applications. So, what's the solution? That's where the brilliant minds behind this paper come in. They introduce ViPER, which stands for, well, it's not super important what it stands for. Just know that it's a self-bootstrapping framework specifically designed to enable iterative evolution through self-critiquing and self-prediction. It's like teaching a computer to not only see but to truly understand what it's seeing, and then to use that understanding to get even better. Now, to truly grasp the brilliance of ViPER, we need to step inside our imaginary memory palace. Picture a sprawling, futuristic research lab. In the first room, captioned self-refining, VLMs are learning to see widely. They take an image and generate a description, but then, here's the twist, they have to critique and refine their own captions based on the visual information. It's like they're constantly asking themselves, did I really capture the essence of this image? Am I missing any crucial details? This process helps the model revise errors or biases in its generated textual descriptions through deconstructing visual information and self-reflection. Now, in the second room, visual operation predicting, VLMs are training to focus accurately. In this stage, the model is presented with two similar images with slight differences and must infer the visual operations or edits that have been applied. Imagine you have two photos of a park, but in one, a bird has been subtly moved from one branch to another. The model has to identify this change and describe the visual operation that caused it. No big deal, right? Except, this process trains the model to focus on key information and understand visual operations based on differences between image pairs. So, how does ViPER work its magic? Well, it cleverly integrates data synthesis and reinforcement learning into a closed-loop system. Think of it like a self-sustaining ecosystem where internally synthesized data directly fuels the enhancement of perceptual ability. This creates a self-reinforcing loop where generation and learning are intertwined, eliminating the need for external bootstrapping and thereby establishing a self-evolving paradigm. To put ViPER to the test, the researchers created something called ViPER 10K dataset and yield Qwen ViPER series perceptually enhanced from Qwen 2.5 VL. They pitted Qwen ViPER against other state-of-the-art models on 7 comprehensive benchmarks, and guess what? Qwen ViPER consistently demonstrated superior performance, achieving significant improvements on fine-grained perception tasks. That's right, folks, ViPER empowers VLMs to undergo self-evolution on perception-centric tasks. It's like watching a digital caterpillar transform into a visual butterfly. This research not only improves the visual perception abilities of VLMs but also provides concrete evidence for the reciprocal relationship between generation and understanding. It suggests that the more a model generates, the better it understands, and the better it understands, the better it generates. It's a beautiful, symbiotic dance that could pave the way for more autonomous and capable VLMs. Now, you might be wondering, Ernis, why should I care? Well, consider the implications for fields like medical imaging. where precise visual perception is critical for accurate diagnoses. Or think about robotics, where robots need to understand their surroundings in order to navigate and interact with the world effectively. The possibilities are truly limitless. So, there you have it, ViPER, a self-evolutionary framework that's empowering VLMs to see the world with greater clarity and understanding. It's a testament to human ingenuity and a reminder that the quest for knowledge is a never-ending adventure. Keep exploring, keep questioning, and never stop being amazed by the wonders of science. Until next time, this is Ernis, signing off.